We're going to do 1.5 and 1.6. This is just a quick refresher on solving inequalities. And solving inequalities is the same as solving equations, except one big major rule. Ding, 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 ding. Write this down. If you multiply or divide both sides by a negative number, you need to change the inequality. So for this first one, we're going to solve and graph. Negative 3x plus 7 is less than or equal to negative 23. So I'm going to subtract 7. Just because I'm subtracting 7, I'm not changing the inequality there. And I have negative 3x is less than or equal to negative 30. Negative 23 minus 7 is negative 30. Divide by negative 3. This is where I'm dividing both sides by a negative, so that's going to change. It's going to be x is greater than or equal to positive 10. Okay, so here's my graph. When I go to graph it, I start at 10, positive 10. I have a circle. Is it open or closed? When it's the equal bar, it's going to be closed, whether it's less than or equal to, greater than, equal to. If it's not the equal bar, it's going to be an open circle. And this is greater than 10, which is going to be to the right. So for this one, I have 2w minus 5 divided by 3 is less than 4. I'm trying to get this w by itself. And it's in the numerator of this whole fraction. So I first have to get rid of that part as a fraction. I got to get rid of this denominator. So all of this 2w minus 5 is being divided by 3. And I can do that inverse operation, multiply by 3. I'm multiplying by both sides, but I'm not multiplying by a negative, so I don't change the inequality. It's still less than. Now it's just solving. Add 5. 2w is less than 17, and divide by 2. So w is less than 17 over 2. You have to understand, if you get a fraction, that's okay. You got to know where that falls on the number line. So 17 divided by 2, well, 2 goes into 17 8 times, so it's going to be similar to 8 and a half. So this is 8, this is 9, so halfway between, I have my circle. It's going to be open, and less than is to the left. So this is 1.6 now. And what it is it's compound inequalities. So I have 8 is less than 3y minus 7, less than 23. All it is it's two inequalities, two parts. And what you can do, I'm going to show you two different ways to do this. You can split it into two inequalities. Keep that the same. 8 is less than 3y minus 7. Keep it the same. But 3y minus 7 is also less than 23. So basically what you're doing is you're doing this inequality as one, and then you're doing this inequality as another one. So I'm just solving these now. So add 7, and I have 15 is less than 3y, divide by 3. It's a positive, so I'm not going to change the sign. 15 divided by 3 is 5. And I'm going to change it to where the variable is on the left side. So y is greater than 5. And over here, add 7. 3y is less than 30, divide by 3. Y is less than 10. So let me show you the other way without splitting it into two. You can write this down. It's solving the same thing. Basically, you have two inequalities here. So I'm trying to get this y by itself. So I first got to add 7. I would have to do it to all 3 parts to it. Okay, so that makes this 15. That makes this 3y. None of the signs change. Where if the signs change, you'd have to change both of them and divide by 3. It's a positive 3 again. So I get y is greater than 5 is what that says. 5 is less than y. And y is less than 10. So what that means is y is between 5 and 10. This is an and problem. With these compound inequalities, it's either going to be and or it's going to be or. Okay? So this is an and problem because it's between these two numbers. It's y is greater than 5 and y is less than 10. So it can be written like this, but it can also be written like this. Either one of those is okay. So when I go to graph it, I have a circle on 5, and that's going to be open because it's not equal to. I have a circle on 10. Y is greater than 5 and less than 10. The and problems should be shaded between the two circles. You could also have an or problem. Okay, and so what this one is k plus 6 is less than -4, or 3k is greater than or equal to 14. And then these you're just solving them separately like I did the last one when I split that and solved them separately. So I subtract 6, k is less than -10. And this one, divide by 3, k is greater than or equal to 14 over 3. So make sure you put that or in between them in your answer though, whether it's an or an and. If it's written as that compound inequality with the variable in the middle, that is only for an and problem. If it's an or problem, you need to split them into two inequalities and write them separately. When I'm graphing this, I have two circles, and this one on -10 is going to be open, and I'm graphing where k is less than -10, so it's going to go to the left, and then k is greater than or equal to 14 over 3. Well, 14 divided by 3 is going to be on the number line between 4 and 5, and that one's going to be closed and shaded to the right. Again, this is the same as solving equations. When I have an absolute value, I have to do the original without the absolute value. X is greater than 5, and then you need to split it, and it's going to be x, and it's going to be -5. But when you go to the negative, just like when you're dividing by a negative or multiplying both sides by a negative, you need to change the inequality. So this is going to be x is less than -5. So when you graph that, I have x is greater than 5, so that's here, and greater than is going to be going to the right. And then x is less than -5, and that's going to be here, open, and that's going to be going to the left. So from this graph, you should see that this is an or problem. Okay, and with this one, you have x is less than 3, x is greater than -3. And here we have an open circle on 3, an open circle on -3. And so it's going to be greater than from -3, less than from +3. So what that is going to be between the two. And this is going to be an and problem. And the trick to remember when it's absolute value, whether it is going to be an or problem or an and problem, is once you get the absolute value by itself, if you have a greater than or equal to, it's or. If you have less than or equal to, it's and. So the way we say it is greater, less than. And you'll hear me say that greater, less than. If it's less than, it's an and. If it's greater, it's an or. Okay, so just like in the absolute value equations, you can't just solve it and then put a plus or minus on it. You have to solve it at the point that you get the absolute value by itself. That's when you switch it into the two inequalities in this case. So in this case, the absolute value is already by itself. So I have 6y minus 5 is greater than or equal to 13. And this is a greater, so it's or 6y minus 5 is less than or equal to negative 13. Okay, so when I solve it, add 5. 6y is greater than or equal to 18. Divide by 6, y. And I divide them by a positive, so y is greater than or equal to 3. Or add 5, and that's going to become negative 8. Divide by 6, and that reduces to negative 4/3. Understand that just because this is a negative, I don't change the inequality. It depends on what you divided by. I divided by a positive 6, so I don't change the inequality. So when I graph this, so y is greater than 3. That's going to be here. It's equal to, so I'm going to fill it in. Greater than is going to be going to the right. Negative 4/3, where is that on the number line? Well, it's on the negative side, and 3 goes into 4 once. 1/3 is remaining, so it's going to be about 1/3 between 1 and 2, and that's going to be closed. Okay, so here are the U-tries. Go ahead and try these. Pause it, and I'll give you the answers here in a little bit. But first, I'm back with the jokes. All right, what do you call a man who rolls in leaves? Russell. Get it? He's rustling around in the leaves. Russell. All right. Well, here are the answers to the U-try. X is greater than 28. Y is greater than 4, greater than or equal to 4, less than or equal to 7. So that's an and problem. X is less than negative 1. X is greater than or equal to 4. And then the last one, X is greater than or equal to 3, or X is less than or equal to negative 1. When you're graphing from here on out, any circle you get, if you want to shorten it up, you don't have to go all the way from one to the other. Even though I could have with these, I wanted to show you what I expect in case sometimes they're really far apart from each other. Just put 3 notches on each circle, so one on each side of each circle that you're drawing. So there's one here, and it's on the negative 1, and that's fine. Okay, and that's a little way to shorten it up. Just make sure you have them in order, and give me the numbers on each side of it.